Alright guys, here we go with the actual questions. This is a short section, only 6 questions we're going to do. Oh wait, well 5 and the last one has 2 parts. So basically 6 questions. And your homework is going to be along the same lines. Alright, let's jump into it. So problem number 1. Find the present value of an annuity if m is equal to 1050. Also, just kind of like heads up, we are eventually going to see all these kind of questions combined, and you're gonna have to distinguish which formula to use. So when you see the word annuity, remember it has 2 options. It could be the annuity formula from before, or it could be the one that we're using now. The difference, the thing that's going to tip you off is it's telling you the present value. Present value means that you want to know the value that you can afford today to take a loan. And you know the monthly payments already. And so you can figure out the p value. We know m, so we're not going to use the formula that solves for m. We want to use the one that solves for the missing thing. Alright, so we're using this guy right here, right? Number 1. And all it is going to be like this. P is equal to 1050. And let's see. Doesn't work here. Okay, 1050. Let's use parentheses. Parentheses for this big bracket first, but then I need another set of parentheses for the numerator if you're just typing it into a normal calculator. 1 minus parentheses for that 1 plus r over n. So 1 plus r is 6%, so 0.06 divided by, it says n is not given to us, so we're assuming for n to be 12. Exponent, well, your exponent might look something like a to the b or something, or caret, depending on your calculator. Remember, exponent is always in parentheses. So exponent, I'm going to write my negative sign first. Be careful, not the subtraction sign. You have a negative sign if you're using a standard calculater. This one actually doesn't matter. But a lot of regular calculators will have a plus minus sign for minus instead, or minus in parentheses. So n is equal to 12 again. Negative 12 times t, which was 30 years. 30. Okay, close the parentheses for that exponent. And then I'm going to close the parentheses for the numerator. And then I'm going to divide by the denominator in parentheses. So r is 0.06 divided by 12. Close the denominator parentheses, and then one more time close the bracket parentheses. Actually, this bracket parentheses is not really necessary because if m is on the top, the same as it being out to the side, it doesn't really make a difference. But you need at least 1 for the numerator here. Okay, so let's type that in here into our calculator. 1050, 1 minus 1 plus 0.06 divided by 12. Close it. Exponent. Negative 12 times 30. Close it. And then close the numerator. Divide. New parentheses for the denominator. 0.06 over 12. And what do I get? I get $175,139.20 to the nearest cent. So that's just what I was supposed to get here. Right on. Okay, kind of summarizing what that means. That means if you have an interest rate of 6%, let's say you want to take a mortgage. 6% is actually pretty high right now. I was looking at the average, it's like 3.75 is around normal percentage rate currently. So that means you could actually probably afford more. In fact, let's just see, just out of curiosity, what that would be if this was, let's say 3.75, which is like the current interest rates I found online. Okay, so a little bit better. You could afford $226,000 house, that means, or a mortgage for that month. Maybe you have extra money that you use for a down payment first, so maybe you can afford something a little more than that. Alright, so that's assuming that you have $1,050 to spend per month. Then this is how much you would have at 6% here. If that is to the current interest rates of about 3.75%, this is how much of how large of a loan that you could afford. You're gonna pay $1,050 per month. That's how much you can borrow. Okay, number 2. Evaluate the amortization formula if P is equal to 14,000. Okay, so smaller value. This is probably more for like a car or something that you're gonna buy. let's see, same thing. Just gonna replace a few values here. Oh, I'm sorry. This is not. This is telling us p. So since it's telling us p, then I'm obviously not going to use the formula that solves for p, right? That doesn't make any sense. So I want to use the formula that solves for the thing I don't know. So this is the guy I want to use. And let's see, I have p is equal to 14,000. So it's going to be m is equal to 14,000 on the top, multiplied by what is it? Rate is 0.05 this time. Okay, question number 2. Divided by n, which is doesn't tell me. So again, I'm assuming n to be 12. Divided by 12. Can't type 12. Okay. And then you notice I didn't write parentheses for my numerator. I could have, but in this case, it's actually not super important as long as I remember to keep my denominator in parentheses. Or you know what, below, as good practice, let's just keep it all in its own set of parentheses. So numerator in its own set of parentheses. I'm going to hit divide, and then denominator in a new set of parentheses. So parentheses 1 minus, and then the next parentheses 1 plus 0.05 divided by 12. Close that one. Exponent to the negative 12 times t was how many years? 5 years. Okay, so this sounds like a car loan, 5 years, or maybe like, what is it, like three years is typical, 3 to 5 years for a car loan, something like that. Okay, so yeah. Okay, so close the parentheses for the denominator here. This one I just typed in. That's to match up the denominator starting parentheses there. So then you type all that, hit enter. Okay, let's see what it looks like in my decimal calculator. 14,000. Let's keep it in parentheses. 14,000 times 0.05 divided by 12. Close. Divide by new parentheses 1 minus parentheses 1 plus 0.05 divided by 12. Exponent negative 12 times 5. Close. Oops. Typo here. I'll type something weird. Okay. Negative 12 times 5. And I get $264.20 to the nearest cent. So that matches what I was supposed to get here. This is telling you if I have a loan for $14,000 at 5% interest over 5 years, this is my monthly payment. $264.20. Alright, just out of curiosity, let me ask a follow-up question. How much would you end up paying overall? And how much did you pay in interest above the actual loan amount? So $264.20. You're making that monthly, so 12 times for 5 years, right? Times 5. So times 12 times 5, that comes out to 15,852. So hey, not like you're not happy about it, but not so terrible compared to the type of interest we calculated in the previous section, right? Where you just calculate everything off the top. So we pay in interest, let's see, 15,852 minus the 14,000. We paid $1,852 in interest. That's at 5% over a 5-year period. Okay, out of more curiosity, what would it have been if I had done the simple add-on interest? That would be 14,000 times 0.05 times 12. Right, 12 times per year. Oh, I'm sorry. Times, not 12, times 5 years. 3,500. So 3,500 would be the simple add-on interest compared to 1,852. So almost about half, yeah. Little less than double if you did the add-on interest. Okay, that is number 2. Oh, I forgot to write 2. This is 2 that we just did. And the answer was here, 264.20 to the nearest cent. Alright, let's do one more, and then I'll take a pause. I'll pause the video after one more. So we're looking now at number 3. Find the monthly payment for the loan. Okay, so right away I know I'm gonna be finding M again, right? Find the monthly payment. That's key. So this is the guy I want to use. Your $395,000 condominium bought with 30% down payment, and the balance financed for 30 years at 4.25%. Okay, so there's a couple of things going on here. You're buying a $395,000 condominium, but you're first making a 30% down payment. So this is what you assume that you have saved up. Or when you buy a house, you gotta make some down payment. 30% is pretty large, but let's just go with it. So how do I figure that out? Well, I take my original $295,000. There's not much of a formula to this. You're just multiplying it by the percentage. So percentage is 30% is 0.3, right? That means you're paying right off the top $118,500. Okay, so that means how much are you gonna borrow from the bank? You have $395,000, and you're subtracting that down payment that you made. This is like assuming you have the cash yourself or something, or for some other avenue. So you're making a payment of $118,500, meaning you're gonna borrow this value, $276,500 from the bank. All right, so let's just start writing out what we know. We know P is equal to $276,500. We know the rate is equal to 0.0425. That's the interest rate. We know T time is 30 years. And it doesn't say what N is, so we're assuming monthly payment. Oh, it does say actually, it says monthly payment. So N is 12 for sure. And is that it? Those are the only variables we need for the formula, right? If you look at it, it's got an R, it's got an N, it's got a T, and that's it. Oh, I'm sorry, and a P. We're looking at this one. P, R, N, T. So I just plug those values into this guy, and it's going to tell me what my monthly payment is going to be. So M is equal to P, which is, oh, I just zoomed out of the screen. So 276,500 multiplied by the rate, which is 0.045, divided by N, which is 12. Close it, and then make sure that numerator is in parentheses, right? Divide by the denominator in its own set of parentheses. So parentheses 1 minus parentheses 1 plus 0.0425. Divided by 12. Raised to the, in parentheses, negative 12 times T, which was 30. 30 years is a typical time period for mortgages. Usually it's either 15 years or 30 years. And I get 14,000. Okay, this is different from what I have written here, so maybe I made a mistake somewhere. Let's see. Oh, 276. Oh yeah, I wrote the wrong value here. This is 0.0425. Not 0.045. Okay, so then I come out with $1,360.21 to the nearest cent. So that means this is your monthly payment, $1,300.60. Oh, I said that wrong both times, yeah? It's $1,360.21. There you go. Okay, I'm going to pause this video now, and then we'll do the last 2 questions in the next one.